Okay, so I'm Jorge Heraud, CEO of Blue River Technology. I'm also one of the co-founders. We started Blue River in 2011. Blue River was acquired by John Deere about 2.5 years ago. So now I'm part of John Deere and Company. So what I'm going to be talking about is how we're using computer vision, machine learning to create intelligent machines to solve huge challenges in agriculture. In particular, as Abby was saying, I'm going to be talking about weeding, weed elimination, which is one of the areas that we're working on. And I want to start by giving you a little bit of context of what the current state looks like for weed elimination. Weeds, maybe just to give a little bit of context to those new to agriculture, is one of these problems that farmers need to deal with. Agriculture is not possible if you don't eliminate weeds. What happens is that the crops that we're growing are all bred and tailored to produce, to turn the energy from the sun into crops and things that we harvest. Weeds, on the other hand, are all targeted about growth and growing very fast and reproducing very fast. So naturally, weeds are just selected to outcompete crops, right? We've been trying to eliminate crops. We've been trying to eliminate weeds for 10,000 years as a human species, and we haven't been able to do it. That's because weeds the weeds that remain are very, very competitive. They grow very fast, much faster than crops could possibly do it. So the way that farmers are doing that today is shown in this picture. You grow the crop, and you use the herbicides. In particular, this machine seen here is applying a chemical called glyphosate, or Roundup, that was created popularized by Monsanto, and it's used in conjunction with GMO seeds. The herbicide would normally kill all plants. It disrupts the photosynthesis process, but the GMO seeds were created in certain crops so that they resist this herbicide, so they don't die when the herbicide is applied. So it's a very efficient way of doing it. You come with this machine, you put this cloud of herbicide, everything gets applied. Not only the crop, but not only the weeds, but also the crop. Everything gets covered, blanket covered with this chemical. And the weeds die. The crops that have been genetically modified to resist it don't. But it has a number of problems. Probably the biggest one of them is just similar to what is happening in the world of antibiotics. The weeds have become resistant to this chemical, and now they're not dying, which is a big problem for farmers because they rely on this method. And also, it's pretty wasteful. You're putting chemicals everywhere just to kill the weeds. So the farmers are facing these big challenges. They have a product that doesn't work anymore, a product that is under a lot of scrutiny from the environmental standpoint. Consumers don't like chemicals in their food. There's also problems in the economic side of things. Input prices, this includes things like seed and herbicides, are becoming more and more expensive. GMO seeds are very expensive in particular, but the crops are not getting any more expensive. So they're under a lot of pressure to try to reduce the cost of GMO seeds and cost of herbicides if they can. And the other one is that there's a lot of back pressure from consumers and regulators against GMOs. GMOs have a fairly bad name, and a lot of people are going to organic or other ways to stay away from GMOs. So these are very big challenges that farmers are facing. It doesn't work, it's expensive, and consumers don't want it. So how are we solving these challenges? We came up with this way of using computer vision and machine learning in real time. We have a machine that we call CN Spray that images the field as the machine drives through it. It looks at every square millimeter of the field. It creates an image of the field as it's driving very quickly. We use machine learning to identify which ones are weeds, which ones are crops, and then we selectively spray the weeds and only the weeds. We don't spray the crop. We don't spray the ground. We spray only the weeds. And this is a very effective way of doing it. And the thing to note is that we do it very fast as the machine is driving through the field at speed somewhere in the 12 to 18 miles per hour, which is a typical speed at which this operation is done. And so what we do is we put the camera slightly in front of our spraying nozzles. We have about 2 feet of distance, and during that distance, the time that it takes the machine to travel that, we make a decision on which ones are weeds, and we spray the weeds and only the weeds. It's here's the same machine I had shown you before. That is the typical machine that is used by farmers. It's a very productive machine. And if you look carefully at this image, you can see some spots that are blue. These are we just for a test, we put some blue dye to be able to see where it is that we are spraying, and you can see the areas that we sprayed. And we can do this using the same machines that the farmer would normally do in the same way that he's been doing it all the time. Let me zoom in. This is a zoomed in version of what is going on. You can see it a little bit more clearly here, the blue areas where the chemical has been applied. If we weren't using this technology, everything would be blue, right? But because we're using this technology to identify weeds, only the areas where there's weeds have been applied and are blue. And by doing this, we can reduce the amount of herbicides being used reduce it by 80%. So apply 20% or even less. For example, in this example, it's probably even less than 20% of the area that gets sprayed versus spraying the whole thing. So it's using herbicides in the right way, using them for where they're intended, which is applied over the weeds and nowhere else. What comes next? I was asked to maybe give a little bit of my vision of where this goes, and I think it's one element of it is that we start we have the ability to start with weed control, and that's what we're doing right now. There's about $25 billion worth of herbicides that get applied every single year to control weeds, and again, our value proposition is we can use 5 times less or even 10 times less herbicides by using this machine. And what we do is we spray those weeds, but also at the same time we can also spray things to the crop, and that's where it gets very interesting, because there's a lot of things that get sprayed to this crop. There's about $200 billion worth of chemicals that get sprayed to this crop. This includes things like nutrients, fertilizers, fungicides, insecticides, things to protect the crop directly. And there's a very large amount of dollars that get spent by a farmer trying to make this crops help these crops grow. And we believe that there's an opportunity to hyper target also what you're doing or what you're applying in a plant by plant basis. Instead of putting fungicides everywhere, apply them only to the plants and only to the plants that need it. Only put it insecticide where it's needed. Only put fertilizer where it's needed. Not put it to all the field. Just put it where it's needed. Move from broadcast to plant by plant farming. And the third element is data services. There's a lot of insights to be had to assist with decisions and making them data driven, and help farmers with the decisions they need to make in order to grow. And that's just in the world of spraying, right? Going from a $25 billion opportunity to an over $200 billion opportunity, which is very, very big. And maybe one comment about agriculture: agriculture is one of those basic needs, right? That is going to be here with us. We all need to eat. We all need to grow. We need to grow food, and we just need to do it in a more sustainable way. Another area that we're thinking about, that we're considering for the future is using technology, autonomous technology, and we've created this prototype that takes advantage of having no driverless technology. having using computer vision, machine learning, stereo pairs to see where the machine is going and autonomously navigate in fields. It's a lot easier to navigate in fields versus in open roads and public roads. There's no traffic. There's no traffic signs. There's basically no people. You can stop. You go a lot slower. So chances of creating any damage is much slower. And by removing the cab, you can enable machines that are lighter, that compact the ground a lot less, which has a lot of benefits, and that are very, very precise. So that's where I see this type of technology headed, combining the high precision of farming on a plant-by-plant basis together with autonomous technology and taking advantages that the two things together can bring. And if you go back to the where I started, which is the huge problems that the farmer is having, this technology is solving these huge challenges that the farmers are having. We are reducing the amount of chemicals, so huge environmental impact, a factor of 5 or 10. We're reducing the amount of dollars that the farmer needs to spend in inputs, and we are reducing the need for GMO crops. So anyhow, that's my view on the opportunity on this particular area in agriculture in weeding. And maybe a last comment I'll say is that computer vision, I know I'm preaching here a little bit to the choir, but computer vision machine learning is absolutely a game changer. It's absolutely a game changer in agriculture, but it's absolutely a game changer to the world and to things that can be done. Every time we go to show this to a farmer, we get this blown away looks that are just priceless, right? The most common quote we get is, "I never imagined this being possible," right? And I think that is not only applicable to weeding, which is what I've been talking, but applicable to all agricultural and applicable to many industries. So anyhow, you guys are working in exactly the right type of technologies and the right type of problems. Thank you.
Thanks so much for sharing, Jorge.